Okay. Uh, 354, Russian doll envelopes. You have a number of envelopes with width and height given as pair of integers, WH. One envelope can fit into another if and only if both the width and height of one envelope is greater than the width and height of the other envelope. What is the maximum number of envelopes can you Russian doll? Rotation is not allowed. Okay. One thing I would say is I would really love to know what n is, but it's fine. Um, okay. I mean, but I think this is what do they call it? Longest path in a DAG, and you could draw it like if you think about it in a graph problem, you could draw a line, a directed line from a node which contains W and H to another node if and only if it fits inside that node, right? And then with that, you get a DAG because there's no cycles, because there's no way, if an envelope is smaller than physically smaller than another envelope, there's no way to make a bigger envelope or like you know what I mean? Like there's no cycle because you get if it's smaller than envelope, then the transitive probably will always hold, and like there's no weird way to be like okay, this mini envelope somehow can hold a bigger envelope, right? At least in this case. So you have a directed graph and it's asynchronous, and you want the maximum number of envelopes, which is just the longest path on that DAG. Um, so yeah, and there's a standard n square algorithm. I think even n log n maybe, but I'm gonna just do the n square one. Uh, yeah, which I think is standardish, but I'll type it out. So well, I mean, I'll still try to solve it. But let me know if you have any questions. Okay, now first we want to sort the envelopes just to make things a little easier. Um, it's just like something like that. Does that work? Without the core lambda. That's what happens when you switch back and forth between languages. That's why. I also think I just confused some stuff. That's why. Yeah, okay. So now it's in increasing order, so yeah. Yeah, okay. So now you know that the first element is always going to be smaller than yours. Oh, sorry, the first index of an earlier element will always be smaller than, so you only have to check the second index, right? Okay. Um, how do I do it? What do I go next? Yeah, okay. This is going to say one because you just have to its own envelope. And the second element, which is the height, is is it strictly greater or yeah, I guess it's strictly greater actually. So you do have to check. My bad. I lied a little bit. Um, envelope is really hard to type. So that means this is in the graph. Then Clone is equal to envelopes up to that point, which is j plus 1. First and clone. Otherwise, append best. And then now we just, I guess we just keep a max. What do we name this? I chose some terrible names in the past. Okay. Just a few more. Oh, that's just YOLO. I feel like I said that last time. Oh, time limit exceeded. Yeah. All right, let's see. That's what I was worried about. It's n square. Maybe n square is too slow. 2 seconds. What is the? Let's just put out n. Just to make sure that I just assume n squared would be fast enough. Maybe I shouldn't. 4,000. I guess 4,000 is kind of big, so maybe we need a. I wish they kind of told you though. Then I would not have. Well, I may have at least thought about it a little bit. We sort it. Is there greedy-ish way? I mean, I'm just thinking right now. I'm thinking about the number of candidates, and I guess there's an n log n one, but it's kind of annoying to code up. Maybe. Yeah, but I guess if you have to, you have to. Okay, fine. Let me look at my submission. Was I close? Yeah, I was near the end. Okay, fine. But it's either that or I'm also trying to think if is this fast enough in another language? Is it like a C++ thing, Python thing? Let me just give it a quick go. No pun intended. I could also do it in Go, but I hope it's not a Python specific reason. Let's see. I could type this pretty quick. This one's 5,000. Oh, I need sorting. This is not going in that case anyway, but yeah, okay. That works out. I mean, kind of. We're doing this for optimization. I guess I might as well create this space. Maybe that size. Actually, everyone's fast enough now. Oh man. Oh, no. I need to do that when I was typing it, but forgot. Yeah, it's much faster, but also wow. So, have I typo somewhere? This one. Size. Oh, you're right. You're right. Thanks. Man, this has been a long day. Yeah, yeah. Wow. What happens when you take so this is much faster, but well, it was about 6 times faster than the Python version. I mean, there might be things we could have done Python optimized, but let's see if that. Oh man. Oh, yeah. Let's forget about this. I don't know why they let me run it in here, but not the other thing. But okay. Let's forget the order actually. That makes me kind of sad actually, but I mean, I think for a problem like this, I'll get into it. I mean, I would say so. First of all, this is the longest path in a DAG, which again is a dynamic programming problem, but this is maybe more standard in that there's probably a Wikipedia entry, so you could definitely DAG in it. I say that, but I'm not sure. But it's one of the more standard E ones as soon as you can recognize it, and probably straightforward because you do it in n squared time. You just have to define the DAG and sort it in a clear way, which, if it's a DAG, then you just have to do a topological sort, which in this case the actual, regular sort does. So that's why I get away with it. It's n squared time and of n space. Maybe I should read it. Whatever. So that's kind of the problem. I mean, I don't know if this merits much of a. I mean, I could clean up some code. I mean, there's some like naming things that I could be slightly better about, but at the end of the day, this is like 15-line function, so I'm not gonna get into that. I mean, you could name things as much as you like, isn't it? I don't know. But the part that makes me sad, obviously, is that my Python code. I mean, definitely, I guess if this was in an actual interview, this is if they're only looking for n square algorithm, this would be good enough, and it should be good in any language. Maybe I could do some optimizations here and there, but I think I could do better. No, I mean, to be honest, I don't know if I am a Python enough expert to know where I could optimize. I mean, maybe I could preset the array so that we do fewer appends, but the difference was like a matter of I don't know. I mean, it was a big difference. I think there was like a 1 second difference between Python and C. So I don't know how much I could have optimized that away. So let's just assume that this is good enough, even though it failed the test because I wrote a C version that's clearly also a C++ version. That's essentially the same, but so I don't know. So that's kind of low. I mean, that's unfortunate, wasting me a little time, but that's fine. But I still think Python you should be able to do. Yeah. So to answer AA Master Legends, I think you should do. I think one is practice Leetcode with the purpose of understanding the problem, and sometimes like I would actually put this under kind of framework problem, or not framework, because framework means something in programming, but like it's a Leetcode platform specific issue for this particular problem. So I would still recommend Python for because it's easier to it makes it harder for you to do dumber things, or like just easier syntax, right? Like you don't have to worry about as much though. I don't know, it depends on which side of the strong type stuff you like. Because like you could do a pen and stuff like that way easier. But I mean, you could do that in C++, in the STL if you like. But anyway, I generally recommend Python so that you could focus on the algorithms, and then after that you could focus on, I don't know, the optimizations or what, afterwards. But yeah, and it's kind of unfortunate that this problem highlights it. But otherwise, this is a very straightforward problem. Even though this is on a hard, this is a hard. You know, either this or something very similar. I mean, essentially, there'll be similar problems like this, except for maybe like this is essentially the compare function for the DAG, or like to see if there's an edge between two nodes, and maybe if they word certain things differently, this would like everything would still be the same except for this line, pretty much. I mean, maybe better naming and stuff like that. Maybe sorting is a little different, but essentially you get this problem in different variations. So I definitely recommend it, and it's something that is relatively textbook-y in that there are probably good YouTube videos out that would explain this. So I'm not gonna deep dive into this too much. It is only like 20 lines of code, but yeah, I think going back a little bit meta is that focus on learning the algorithms. I think I actually recommend just doing Python, focus on algorithms. If you get stuck or if something looks sketchy, just go to discussion forum and ask people, look for their answers. At least make sure that your time and space complexity is roughly the same. Then at the end of the day, You learn something from it, then it doesn't really like I don't know, whether you get it submitted correctly is uh, it doesn't really matter. It's just the numbers on a website somewhere. Um, but I forgot what I was thinking. Oh yeah, I guess just to kind of complete this problem, I think I skipped analyzing the complexity, which is of sort of n squared because there's you know an n squared loop. It's n choose two even, but and of n space, which I don't think could do better at the current formulation. So yeah, and that's pretty standard for longest path in the DAG. So yeah,